Hello, welcome to Fractions with Doug. Okay, we are going to be talking about fractions this week. There will be some adding and subtracting fractions, which is very important. So it is an important lesson, but I don't want to go too quickly through it. We need to practice. We need to take a good look at what we're doing so that we can understand it. What is going on? I know that not all of the students will be here yet, so I am going to talk about the other things I talk about sometimes. I'm holding this thing in my hand, you may be noticing, because it's part of what I will be talking about. Here I am wearing my jersey of the week is the Jamaica national team soccer jersey, which I bought when I was on vacation in Jamaica as a souvenir. It's a pretty cool looking one. But I'm also wearing a sweater. Why is he wearing a sweater? Well, I am in my basement, but that's not always a reason to wear a sweater. It's also October. And I live in Canada, and the weather is a little bit colder here than maybe where some people live. And it is already definitely autumn. There are leaves falling from the trees. I have a lot of chores to do. But what the autumn weather also does, besides providing chores, is it puts us in the mood to do crafts. Now, my wife, Vanessa, who I also refer to as Bunny, really likes doing crafts. She makes all sorts of interesting things, and this is one of the things that she makes. So what she's been making in the past few days are autumn wreaths. This one is designed to be hung from the bedroom door of one of our grandchildren. And I have another one, I'll show it to you later, because I made a word problem and I want to deal with the word problem later. And the word problem has to do with Vanessa making autumn wreaths. So that's why I have that. And the only other thing to talk about before we really get going is we have the beautiful assistant Mocha here. I may as well show her to the camera. Come here. Come on. Come here. Okay. Oh. She has gotten a lot shaggier since the last time I showed her to the Supercharged students, because it really doesn't take long with her. 2 weeks and she goes from being really sleek and smooth to being this sort of curly-haired thing. She's very cute, but she is also not necessarily perfectly well behaved. Lie down. Stay. Just a few minutes before we started, I caught her eating a piece of broken chalk that was on the floor. Dogs will eat anything. So no, dogs are not perfect. They are cute, but they're not perfect. Now we're going to get into the math, the fractions. I need my chalk. Okay. Now, at the end of the last lesson, I very briefly introduced some sort of beginner problems where we add and subtract fractions. We already know a lot about multiplication and division of fractions, but adding and subtracting is a little bit different because, as you know, that involves needing a common denominator. But I'm going to start with a review the way I like to do. So I'm going to review the same sort of questions that I introduced at the end of the last lesson. How about 1/4 plus 1/4? Now, this is an easy one because the denominators are already the same. When we add fractions, we have to have a common denominator. And when we subtract fractions, we also have to have a common denominator. And that creates a couple of extra steps that the students have to learn. It's not quite so quick to get into as multiplication and division, where you immediately start doing things with the numerators, doing things with the denominators. With adding and subtracting, you have to make sure the denominators are common first. But in this problem, they are. Both of these fractions has 4 as the denominator, so we can go ahead and add them. Do we add the denominators? No. We multiply denominators when we're multiplying and when we're dividing fractions, but we do not add the denominators when we're adding fractions. That is an important thing to know. We need the common denominator because it's not only common between these two fractions I'm adding, it's also going to be the denominator for the answer. So the first thing I'm able to do is realize, oh, okay, it's something quarters plus something quarters. The answer will be something quarters. And then the numerators I do add. So I see 1 plus 1. 1 plus 1 is equal to 2. 2/4 is the answer. It is the correct answer. It is quite an easy one. Yes, we can reduce this fraction in the answer, but I'm not going to do that yet. We'll talk about reducing fractions a little bit more later. But let's do another quick subtraction. My subtraction is 7/8 minus 4/8. Same rules. We have to have a common denominator to do subtraction, but this question already has a common denominator. The denominator is 8 for both fractions, and it will be 8 for the answer. And then how do we do the numerators? Very similar to what we're doing here, except it's a subtraction. So we're doing 7 minus 4 equals 3. We have 3/8, which is one of my favorite fractions because I like woodworking. And then we think about this. I know the students have seen a lot of things, and you've seen reducing fractions, for instance, and we've reduced much more complicated fractions than, say, 4/8. But the students are probably already starting to get a feel for the idea that 4/8 is equivalent to 1/2. It can be reduced to 1/2 if we reduce it to lowest terms, because 4 and 8 have a common factor of 4, and we can divide both of them by their common factor. So 4/8 equals 1/2. That means that this is telling me that 7/8 minus 1/2 equals 3/8. It has to be the same answer since we know 1/2 is equal to 4/8. So then you get to see that it is actually possible to do this subtraction even if the denominators are not common, at least not at first. But it's not going to look like this. We're not going to say 7/8 minus 1/2 and write an answer. We are going to make sure the denominators are common first, because we know that if we have 1/2, we can make 4/8 happen. So that is really what the trick is. The trick is how do you make the denominators common? Okay, doing that requires us to expand fractions. And expanding fractions is something we haven't been doing in the lessons that I've been teaching this year, but we have to get into it because it becomes necessary when we are working with the common denominator. Okay, so expanding fractions, though, is similar to reducing. So the first thing that I want to do when I start talking about that is I want to remind you how we reduce fractions. I am taking a quick look at the chat once in a while and at the time to see how I'm doing. And I have Mocha over there. She's still sitting in that same spot on an armchair, and she's watching everything I do. She really is paying attention. So it's nice. It's nice to have an audience member who sits there and she's really paying attention. She's not off doing something else like eating chalk. Okay, so what if we had the fraction 9/12? We know how to do this. We've been doing this already. We are going to divide this fraction by 1. Now, we don't normally show this step, but I like to show this step when I'm dealing with beginners. But I know the students aren't beginners. I'm talking about this because we are sort of beginners when it comes to expanding fractions, which has a lot in common with this. So 9/12 divided by 1, we're allowed to do, because it won't change 9/12 into something else. You can always divide a number by 1, and it gives you the same number as an answer. But we're not dividing it by this form of 1. What we're doing is we're dividing 9/12 by a clever form of 1. And the clever form of 1 is a fraction that has the same number in the numerator as the denominator, which means it's equivalent to 1. It is 1. But which fraction will we choose? We will choose, what number will we choose for that numerator denominator? We will choose the greatest common factor of 9 and 12. How did we do that? We list the factors of 9, 1, 3, 9. And yes, if you're good at it, you do this without necessarily having to show the factors. But we can list the factors if we need to. And then factors of 12, 1, 12, 2, 6. Oh, I don't need another comma there. 3, 4. And that's it. I just put a comma. I had enough space for all of them. 1, 2, 3, 4, 6, and 12. That's the common factors of 12. And the greatest common factor is the 3. So this pattern of steps that we follow, we want a clever form of 1, but to figure out which clever form of 1 we want, we look at the factors of the two denominators, and that helps us to find the one that will work, and we're able to reduce our fraction. 9 divided by 3 is 3, and 12 divided by 3 is 4. It turns out 9/12 is equal to 3/4. It worked. It's a great technique. So the idea of expanding fractions, very similar to the idea of reducing fractions. And we will show this by doing an addition problem. So why are we doing this? We're doing this because we do it as part of the steps of finding a common denominator, which we need to do when we're adding and subtracting fractions. We will start with an addition. And one without very big, crazy numbers. We will start with a fairly straightforward looking addition of fractions problem. 3/8 plus 1/2. Okay, I cannot, excuse me, I cannot add these directly because the denominator is not yet common. How will I find the common denominator that I need? What I will do is very similar to listing the factors of the two denominators. I'm going to be listing the multiples of the two denominators. The multiples of 8 are 8, 16, 24, and it goes on and on. The multiples of 2 are 2, 4, 6, 8, 10, and it goes on and on. I go on and on as far as I have to until I can find numbers that are on both lists, like I did when I was listing the factors. But these are not factors, these are multiples. What are multiples? We're counting up by 8s, and we're counting up by 2s. So multiples aren't that really that strange a thing to do. It's a fast thing to do. Count up by 2s, count up by 8s. Okay, and then we're looking for a number that's on both lists. But with the factors, we were looking for the largest number that was on both lists. With the multiples, we're looking for the smallest number that's on both lists. And the smallest number that's on both lists is the 8. So therefore, our common denominator will be 8. And I'm going to rewrite my problem so that both of the fractions have 8s as the denominator. I can even look ahead and see that the answer is also going to have an 8 as a denominator, but I won't write it yet. First, I want to modify my fractions so that they are over the denominator 8. Now, here we had a little bit of a shortcut because 3/8 already has 8 as its denominator, so I don't have to change that one. But 1/2, I have to convert that into something over 8. And how do I do that? I will erase my list of multiples because we don't need it anymore. Now we know what denominator we need, so we don't have to be looking at this. How am I going to turn 1/2 into a fraction over 8? Very familiar process, not very different from something we've been doing a lot of. We take 1/2 and we multiply it, not divide. We're not reducing, we're expanding. We multiply it by 1. And again, we don't have to show this step all the time, but I like to show it when I get started. 1/2 times 1 will be 1/2 times a fraction that's equal to 1. And the fraction that's equal to 1, what will I use? I say to myself, how do I get 2 to turn into 8? I multiply it by 4. If I'm going to multiply the 2 by 4, I also have to multiply the 1 by 4. I need this to be equal to 1 for this to make sense. So the special form of 1, the clever form of 1, that trick still happens, but when we're expanding fractions instead of reducing, we multiply, we don't divide. So a lot of this is something that we're familiar with already. We just have to get used to doing it in a slightly different way. And of course, 1 times 4 is equal to 4, 2 times 4 is equal to 8, 1/2 is equal to 4/8. We sort of knew that was going to happen. We have 3/8 plus 4/8, and now we have a common denominator, so we can finally add. The answer will have 8 as the denominator, and 3 plus 4 equals 7. I have my answer. Didn't write it very firmly, but now I do. I think this chalk is just about finished. Yes, it is, and this is not meant to be a snack for the beautiful assistant, so I'm not going to let it fall on the floor. I'm putting it on the table here. And now I will load up another piece of chalk so we can continue. Okay, we're doing fine. We were still near the beginning of our time, and we've gotten into some stuff. This is what it's about. Adding fractions is about doing what I was just showing. We want to add the fractions. We need the denominator to be common. We arrange for the denominator to be common by multiplying each of the fractions that we need to by whatever clever form of 1 will make that fraction have the denominator we need. And in this case, the 3/8, we didn't have to change it. We multiplied it by 1 over 1, if you will. We didn't change it, but 1/2 we changed, and that allowed us to continue and finish our problem. So it's just an extra step that has to happen when you're adding fractions. Subtracting fractions works the same way, and we'll get into some examples of that. But first, I want to do some more examples of adding. Let me see. I have some notes on here, and before I take this page away, I want to make sure that I didn't forget anything. Oh, I think I'm good with that page, so I'll remove it. Okay, this page has a whole bunch of addition problems prepared for us. Not crazy difficult ones with simple-ish numbers, simple-ish numerators and denominators, but there are several of them, and that is the point. We need to practice. We need to take a good look at this and think about what we're doing. We can't rush into it just because we look at this and we think, oh, I understand that. That means I've learned this. No, that way lies forgetting. That way lies being confused. You need to practice with math. Okay, so I'm going to put another addition problem up, and I'm going to go through just as much detail as I did the first time in solving it. How about 2/5 plus 3/10? Okay, we want to add them. We know when we add them, we're going to get a fraction as an answer. We can build the skeleton of our whole problem. But, whoa, we can't get right into it. We need a common denominator. How do we do that? We have to find a common denominator. So I'm going to list the multiples of 5 and 10. And I know a lot of the supercharged students are already thinking of what the denominator should be. But just in case someone doesn't realize, the way to figure it out is to list the multiples. I'm going to do this a little lower this time so I don't have to erase them. So we have the multiples of 5 and multiples of 10. What is that? We're just counting up by 5s, counting up by 10s. So 5, 10, 15, 20, and it goes on and on. Now, if I realize later I didn't go on and on enough, well, I can just erase these 3 dots, and I can go a little further and find more multiples of 5 if I need to. 10, 15, 15. Okay, let's erase that, because that's not counting up by 10s. 10, the second multiple of 10 will be 20. Now I'm counting up by 10s. 30, and it goes on. And I stopped pretty quickly because I realized I have already found the smallest number that's on both lists, which is the 10. So it happened again. We found a common denominator. We realized it's going to be 10. And it turns out that one of our original fractions that we were adding is already a fraction over 10. The first time it was the first fraction, but it doesn't necessarily have to be. This time it's the second fraction. So the second fraction, 3/10, is already over the common denominator. I don't have to change it. 2/5, though, I need to expand. So that's why I left some space here. 2/5 times 1. But I won't write the times 1 part. I'm already going to the point of saying I'm going to put a clever form of 1 right away. I need to expand that so it gives me a fraction with 10 as the denominator. I have to multiply 5 by 2 to get 10. So my clever form of 1 will be 2 over 2. I'm still multiplying the fraction by 1 because numerator and denominator are the same. 2 times 2 equals 4. We already knew 5 times 2 equals 10. So this tells us that 4/10 is an equivalent fraction to 2/5, but the magic of it, it is a fraction that's equivalent to 2/5, which is over our common denominator. At this point, it feels like rolling downhill. So the answer will be over 10, and 4 plus 3 equals 7. We have our answer. It does seem easy at the end, but don't try to rush through it too fast because you have to do these important steps. And as you practice, you will find more and more that these steps are happening in your head, that you're able to think of the multiples of the number, you're able to think of the denominators you have and figure out what the common denominator is without having to write down too much. That's great, but don't rush into it. When you're still a beginner, show the steps, use a bit of paper. And if you're ever doing one that seems hard, well, slow down, show the steps. It won't turn out to be hard because these steps work. Okay, I'm going to erase and do a third one. How about 1/8 plus 1/4? Okay, what do I have to do? I have to convert this into an addition of 2 fractions that have a common denominator. What will be the common denominator? I think the multiples of 8 and the multiples of 4. And if I can do this in my head, that's great, but I'm still going to show them. 8, counting up by 8s, 8, 16, 24, and it keeps going. 4, counting up by 4s, 4, 8, 12, 16, and it keeps going. And I don't have to keep on writing anymore because I can see that 8 is on both lists. So my common denominator is going to be 8 again. 1/8 is already over 8. I don't have to change it. 1/4 has to be multiplied by a clever form of 1 so that it gives me something over 8. 4 times 2 is equal to 8. So I multiply by 2 over 2. 1 times 2 is equal to 2. Yes, 2/8 is equivalent to 1/4. And it's easy to see that when we're dealing with simple fractions like these. But this trick will still work when you start having fractions that are not quite so simple to look at. And we're able to answer a question. This is starting to go faster and faster. I hope the students are starting to feel that they're good at it. The answer will have 8 as the denominator. 1 plus 2 equals 3. There's that Doug's favorite fraction again. Why does he like 3/8? Just because he likes woodworking. And that's a fraction that happens a lot when you're in the hardware store. Okay. Now, why does it keep happening that one of my fractions turns out to already be over the common denominator? Well, you could say the answer to that question is because the teacher set it up that way, which is true. Doug set it up that way because he wanted to start with fairly easy examples. But there's another reason. The reason this happens is because 4 is a factor of 8. And when one of the denominators is a factor of the other denominator, this thing happens where the larger denominator ends up being the common denominator that we need. That happened in all 3 of the examples I did so far. So now I'm going to do an example where that's not going to happen because it's not always that convenient, but it doesn't have to be because the techniques we're learning work, no matter whether you're lucky in that way with a fraction that doesn't have to be changed or not. So all of these examples, we had to change only one of the fractions to get it over the common. But what if you have to change both of them? Let's try it. Now, as usual, while the teacher is erasing and writing problems, the student can take a chance to get a sip of water, and I need a sip of water myself. This is calamansi, citrus, and strawberry. Fancy. Okay. The important thing is it is water and it is fizzy and it is good when I am doing all this talking and standing too close to all this chalk dust. Okay, let's add another pair of fractions. How about 4/5 plus 1/3? Make my plus symbol look a little better. Okay, 3 is not a factor of 5. Something different is going to happen, but it's not very different. I still want to write the skeleton of my next step and even the skeleton of the answer, but I don't want to rush into putting any denominators or numerators in there. I want to take my time and follow all the steps. I need to know what the common denominator is going to be. I need to know a common multiple of 5 and 3. I'm going to list the multiples. Let's start with the 5. Counting by 5s, 5, 10, 15, 20, keeps on going. I know what's happening. I know a lot of the students saw me do that and they were thinking 5, 10, 15. 15, of course, it's going to be 15 because the students are already familiar with the multiples of 3 and they're thinking ahead. And that's fine. It just shows that you understand. Multiples of 3, 3, 6, 9, 12. Yep, there's that 15, 18, and it goes on and on. 15 is the smallest number that's on both lists. So 15 is my common denominator. So I'll write 15 as the denominator of both fractions. Now I have to expand both of these. Should I do it all here the way I was doing, or should I find another way of showing it? I'm going to find another way of showing it. It does get a little cluttered on your page, though. So I want 5 to turn into 15. I'm going to multiply it by 3. I know that 5 times 3 is equal to 15. But if I'm multiplying the 5 by a 3, I have to multiply this 4 by a 3. I'm doing the same thing. I'm just showing it here. I'm multiplying it by that clever form of 1, which happens to be 3 over 3 this time. 5 times 3 is equal to 15, and 4 times 3 is equal to 12. I have converted my 4/5 into 12/15. It's really the same number. It is an equivalent fraction, but I have to work with this one as well. How do I turn 3 into a 15? I multiply it by a 5. If I'm multiplying the bottom by a 5, I have to multiply the top by a 5. I'm multiplying it by the clever form of 1, which is 5 over 5. 3 times 5 is equal to 15. 1 times 5 is equal to 5. Now we have common denominator. Both fractions had to be expanded to be over the common denominator, but we can proceed to add the fractions now. The answer, of course, will have 15 as the denominator, and 12 plus 5 is equal to 17. We have 17/15. It is an answer that could be simplified a little bit if I want, but I'm not going to do it because I want to focus on the adding. This is how we add fractions. We do not need one of the denominators to be a factor of the other in order to make this work. Interesting. Let's see what I have next. Let's do one where the numbers are slightly larger, just to prove that we have nothing to be afraid of when the numbers get larger. It might not be as quick to think of the common multiples and the common denominator, but we have techniques to figure it out, so we don't have to do it as quickly. When you need to slow down, you should slow down. Okay, I will erase this one. I will erase these multiples. I'm finding ways to do this where I don't really have to use as much paper, but I'm not rushing into that. How about 1/7 plus 3/10? Notice how I'm leaving a bit more room. It's because I like this thing where I show my expanding of fractions right here in the problem instead of having to use another part of the page. 1/7 plus 3/10. Well, that's going to give me a fraction plus another fraction, and that's going to equal a fraction. I know that's all going to happen, so I'm writing that in. I just like to put something on my page so that I don't have to look at blank space. Okay, now I need the lowest common denominator of 7 and 10. I need the lowest common multiple of 7 and 10. It might not be quite so fast to think of this. And maybe we'll have to make a longer list of multiples. 7. Well, I start with 7 when I list the multiples of 7. And then 14, 21. All I'm doing is counting up by 7s. It's actually fun. 28, 35. And of course, this should remind us of something. This is a line in the multiplication table. It's a line going across, and it's also another line going down. When you find 7 in your multiplication table, well, there's this line that's associated with it, which is counting up by 7s. So counting up by 7s is the same as multiplying 7 by a whole lot of consecutive numbers, if that makes sense, and yes, it does. Okay. 42, 49. I think I'll stop for now. Let's see what happens with 10. Although I have a kind of feeling 10's multiples are all going to end with 0, and I haven't seen that happen here. So I might have to do some more multiples of 7. Counting up by 10s, 10, 20, 30, 40. It's a little messy here. Let me get rid of that. 50, 60, 70, 80. Okay. And it goes on and on and on. But I need to go on and on a little more with the 7s. 49 plus 7 is 56. 56 plus 7 is 63. 63 plus 7 is 70. And we had a feeling that was going to happen. 70 is the smallest number that's on both lists. And it's not a very small number. But we were still able to do it. So therefore, my common denominator will be 70. Interesting. How do I get 7 to turn into 70? Of course, I multiply it by 10. But if I'm multiplying this fraction by a clever form of 1 that has 10 as the denominator, that means I have to multiply the numerator by 10. I'm multiplying 1 over 7 by 10 over 10. 7 times 10 is equal to 70, of course. And 1 times 10 is equal to 10. I can do it. Number's bigger, still can do it. That's good. How do I get 10 to turn into 70? I multiply it by 7. And if I multiply 3 by 7, I get 21. So expanding the fraction starts to be quite quick and easy when you get used to the steps. 7 over 7 is a clever form of 1. It's 1. I didn't really change the number. 3/10 turns out to be equivalent to 21/70. Who would have known that? Okay, but we didn't have to know it ahead of time. We were able to figure it out. And now we can give our answer. We have a common denominator. We add the numerators. 10 plus 21 is equal to 31. I have my answer, 31/70th. Big numbers in it, but just as good as any other fraction. Big numbers don't stop me. I can still do this. Looking at the bunch of other examples I have ready and trying to think about what I want to do and when I want to do it. Haven't done any subtractions yet, so I have to get into that pretty soon, just looking at the time. I think I should do a few subtractions. Yes, it's time to switch over to some subtraction. But we already know that not very much is going to change. We're doing all of the same techniques, but we have to remember that we're subtracting at the end instead of adding with the numerators. Okay, no problem. Nothing to be afraid of. Let's prove that we can do subtractions as well as additions. Okay, how about 9/10 minus 1/5? Okay, I think some of the students are thinking and realizing, hey, we did an addition before where we had 10 and 5 as the denominators. I kind of feel like I know what's going to happen, and that's great. What happens, of course, is that you find yourself adding the same fractions more often than others. And it's going to be the simpler fractions that you add more often than others. And this happens with all numbers, not just with fractions. When students start adding numbers, adding whole numbers like 1 plus 3, 2 plus 4, they quickly become good at a lot of the simpler additions because they see them more often. 1 plus 3 equals 4, 2 plus 4 equals 6. The students will get very quick at answering these questions. And then when you suddenly say, okay, 29 plus 84, then they have to slow down a little bit because the numbers aren't quite so familiar. You don't run into those numbers as often. Well, the same thing happens with fractions. So fractions like 1/5, 9/10, 2/3, 1/4, you'll see them a lot if you practice a lot, and you'll start to get a feel for them, like we're doing right now, because we know that this is going to be a subtraction of two fractions, and it's going to give an answer that is a fraction. We see what's going to happen. I'm not going to list the multiples of 10 and 5 because I did it before. 10, 20, 30, 40, I can say it out loud. I'm not going to write them down. 5, 10, 15, 20. The lowest common multiple of 5 and 10 is 10, just like it was when we were adding. So I need 10 to be the denominator in both fractions. Here's another situation where I got kind of lucky because one of the fractions is already over 10, so I don't have to change that one. How do I get 1/5 to turn into something over 10? I have to multiply 5 by 2 to get 10. So I'll multiply 1 by 2. I'm multiplying this fraction by the clever form of 1, which is 2 over 2. 1 times 2 is equal to 2. 9 minus 2 is equal to, 7. I didn't write my denominator in ahead of time, but I don't have to. I still know, well, the common denominator is going to be the denominator of the answer. It's working, keeps on working. Subtraction is just like addition, except for that one little step at the end. And that's one of the things that makes it not so hard after all. That means if a student understands this and can do this, that means, hey, we covered all 4 of the operations. We already knew how to multiply fractions. Then we learned how to divide fractions. Now we've learned how to add fractions and even subtract fractions. It's amazing how quickly we learned so many things. Okay, but we need to do some more practice. Even though subtraction is the same as addition, the truth is we haven't practiced addition yet enough anyway either. So we're going to keep on practicing more subtractions and more additions to make sure that this really sticks, that we feel really comfortable with the whole process. What's my next one? 11/12. Numbers got a little bigger there. Minus 1/3. That is going to be a fraction minus another fraction, and that will give me my answer, which will be a fraction. I need the common denominator for 12 and 3. I need the lowest common multiple of 12 and 3. I can see what's coming because I already know my factors of 3 and my factors of 12, and I realize, hey, 3 is a factor of 12. I'm starting to get that feel for it because I'm seeing the patterns. Students need to slow down and take a look at what they're doing and think about the patterns that are emerging, because understanding the patterns means you're understanding what you're doing. Being able to do a trick is great. But if you don't understand the trick, you'll forget how to do it. If you know how to do a trick and you understand really how it works, you're going to remember it a lot longer. Okay, so the multiples of 12 and 3, I'll go back to listing the multiples, but I'll do it quickly. Multiples of 12, 12, 24, 36. Keeps going, 3, 3, 6, 9, 12. There we go. We have found the lowest number on both lists, which is the 12. And of course, these keep on going as well, but I don't have to keep going. I have found my common denominator. It is going to be 12. One of the fractions is already over 12. The other fraction needs to be expanded so that it is over 12, over the common denominator. How do I get 3 to turn into 12? I multiply it by 4, which means I must multiply the numerator by 4 as well. 1 times 4 is equal to 4. 1/3 is equal to 4/12. We all knew that. 12 isn't that big a number. It's not that uncommon a number. We deal with 12s quite often, actually. If we measure when we use feet, well, we're involved with 12 inches in a foot. If we're familiar with eggs that come in dozens, although I've seen eggs come in packages 2 dozen, 24 eggs. Okay, but 12 is one of those numbers that we get a feel for because we encounter it a lot. Okay, my answer will have 12 as the denominator. 11 minus 4 is equal to 7. I have my answer. I am finished. I can do subtraction. I can do addition and subtraction. Let's do another one. Now, this thing where it was convenient, where one of the denominators was already a factor of the other, that made us have a few less steps to do. Not always going to happen. So with subtraction as well, we need to make it not happen so that we can prove to ourselves we know how to deal with it. My next example. And again, the numbers aren't getting really big. 8/9 minus 1/4. I'm going to have a fraction minus a fraction. I'm going to have an equals and a fraction. I'm getting ready for all of that. 9 and 4. 4 is not a factor of 9. So it's not going to happen quite so conveniently this time. Let's list our multiples. 9, 18, 27, 36, 45, keeps 49. Why did I write a 9? 45 keeps going. 4, 4, 8, 12, 16, 20. Haven't gotten to it yet. 24, 28. Still haven't gotten to it yet. Sometimes you have to list quite a few multiples. 32, 36. But at that point, we realize what's happened. 36 is on both lists. It's the smallest number that's on both lists. Making sure. 36 is the smallest number that's on both lists. So that will be my common denominator. 36, 36. I can even write a 36 here. Fill in that skeleton pretty quickly. Okay, how do I get 9 to turn into 36? I multiply it by 4. But that means I have to multiply this 8 by a 4. So that I'm multiplying 8/9 by 1. 4 over 4 is equal to 1. 8 times 4 is equal to 32. How do I get 4 to turn into 36? I multiply it by 9. I multiply my 1 by 9 as well. Same reason. 1 times 9 is equal to 9. 32 minus 9 is 23. 23/36, kind of a biggish looking fraction with biggish denominator and biggish numerator, but still, was it hard? No, because we're doing the same thing that worked with the easy looking answers and even the harder looking answers. It still works. The process works. I trust the process. Mocha, do you trust the process? She does. Okay, another subtraction. Before I move on to one of those, let's compare one of those analysis, one of those, let's do it 2 different ways types of examples. I like those. Taking a look at what's going on here. And of course, students are always welcome to type in suggestions for problems, which I sometimes am able to take. And of course, write in answers as well. I like to see that the students are involved. It's not just me all alone here. The students are part of the class. We do this together. So yes, when you're able to type in answers or suggestions, do so. Okay, one more. Making sure that I don't accidentally use one that I've already used. How about nine tenths? Let's write it. 9/10, pretty big. 9/10, but it has a 10, so we're not scared of tens. Minus 3/4. What is my common denominator going to be? What is the lowest common multiple going to be of 10 and 4? Let's try and do this without writing down the multiples, but think and not go too fast. Should I list the multiples of 4 first, or should I list the multiples of 10 first? I think I could do either strategy, really. So the multiples of 10, 10, 20, 30, 40, 50. Hey, 40. What happens is I say the numbers, and when I say a number, I think, is the other denominator a factor of that number? But I have to be careful because, wait, 4 is not only a factor of 40. I said 20 earlier. I'm going to list my multiples. 10, 20, 30, 40. That 40 happened. And 4, 8, 12. This takes a little longer. 16. The smaller number always takes longer, doesn't it? 20, 24. Hey, I can stop. I'm not going to stop. 28, 32, 36, 40. Now I'm going to stop. Look, there's a 40 on both lists, but there's also a 20 on both lists. Well, this is going to happen too. If you make your list of multiples long enough, you're not just going to find one number that's on both lists. Eventually, you're going to find another number that's on both lists. And in fact, we could do this forever. So it means we could find an awful lot of numbers that are on both lists. So all of those numbers would actually be common denominators. But do we always just want a common denominator? Or do we want the lowest common denominator? You may have noticed another pattern. Okay, up there. She was actually standing at my feet and she was starting to eat the chalk dust that's on the floor there. So I think she's better off on that armchair. Stay. Okay, all right. So we could have noticed a pattern that with some of our problems, if we just multiply the two denominators, we'll get a number that is a multiple of both. 10 times 4 is 40, and that happened. In this case, 40 is on both lists. 40 would work as a common denominator. And I could get 40 by doing 10 times 4. So there's kind of a shortcut that can suggest itself. But that's why I'm introducing the idea of not only a common denominator, but the least common denominator, or lowest common denominator. Not only the CD, which is common denominator, the LCD, which is least common denominator or lowest common denominator. So 40 is a common denominator, but 20 is also on both lists. And that's the lowest number that's on both lists. So that's going to be the least common denominator. I want to use 20, but 40 would have worked. Now that I know that my lowest common denominator is 20, I need to expand these fractions so they're over 20. But of course, we're getting good at this because we've been doing it quite a bit. How do I get 10 to turn into 20? I multiply it by 2, but that means I have to multiply this 9 by 2, and I have 18/20ths. How do I get 4 to turn into 20? I multiply it by 5, but that means I also multiply this 3 by 5. 3 by times 5 is 15. 15/20ths is equivalent to 3/4. 18/20ths is equivalent to 9/10. But the most important thing is that 15/20ths and 18/20ths have a common denominator, so we can give our answer. 18 minus 15 is equal to 3. That's interesting. Now, we know that 40 would also have worked. So how about we do this problem again, and we use 40. We don't use the least common denominator. We just use a common denominator. See what happens. And that's part of that experimenting and looking at patterns and understanding patterns that make us really learn things. So 9/10 minus 3/4. Put all of that in its place, give myself a bit more chalk, but I'm going to try using 40 as my common denominator. which means my final answer will be over 40. Make that longer. Okay, so if I want 10 to turn into 40, I multiply it by 4. And 9 times 4, I also have to do, so that I'm multiplying the fraction by 1. 9 times 4 is equal to 36. If I want 4 to turn into 40, I multiply it by 10. Now, we're not surprised by this, because we were talking about how you can just multiply the two denominators you have, and you'll get a common denominator. It just isn't necessarily the least common denominator. I see a couple of comments coming up, and I'm going to look at them in a second. Okay. If 4 is multiplied by 10 to get 40, this 3 has to be multiplied by 10, and that means I have a 30 here. 36 minus 30 I can do now because the denominators are common, and that leaves us with 6 over 40. But wait, what else is going on here? I can see that these two fractions are equivalent, but 3/20ths is already simplified to lowest terms, and 6/40ths isn't. So doing it this way gives me an extra step at the end, at least if I want my answer to be simplified. So I'm reducing. Remember that thing that we were already good at? I'm dividing by 1. I'm dividing by a clever form of 1, which has the greatest common factor of 6 and 40. Common factor. Remember that? With reducing, it's the common factor. 6 divided by 2 is equal to 3. 40 divided by 2 is equal to 20. 3/20, same answer. So what happens? If we use the least common denominator, we end up with a fraction that doesn't have to be simplified, or at least doesn't have as much simplification that might need to be done. If we start with a common denominator that's not the least, it still works, but then we might want to simplify our answer. So which one is faster? Neither one is really faster. This has an extra step at the end, and this had an extra step at the beginning, if you wish. Let me look at these comments. What if you use a larger common factor? Will you get the same answer? When we're reducing, we want to use the largest common factor. In the end, though, we will get the same answer. So that's a question that goes with reducing. What happens if you don't know the LCD? If you don't know the LCD, you figure it out by listing the multiples. So that's a tool you always have, because all the students who are starting to learn their fractions operations have already learned about multiples. And remember, multiples is not a scary thing. It's counting up by 2s or counting up by 4s. It's counting up by the number that you are dealing with to find the multiples of. So that's what you do. Can 0 ever be a lowest common denominator? I don't think we want 0 as a denominator at all, at least not in this level of math. So I would say you're not going, I don't expect you to see 0 as a least common denominator. If the numbers, there's a lot of good questions here. If the numbers are prime, does that matter when you try to find the lowest common denominator? It doesn't really matter. You can still find the lowest common denominator if both numbers are prime. And you're really doing the same steps as when they're not prime. So we don't really have to stop and ask ourselves if the denominators are prime or make sure they're prime. We don't have to do that. Here's a neat one. What if you, when you subtract two fractions, you get a number less than 0, like 1/4 minus 1/2? That would get an answer less than 0. And it will work. And in fact, the techniques that we're doing of subtracting fractions will still work when we have a situation like this. This is going to happen when the first number before the subtraction sign is smaller than the second number. What that's doing is it's creating an answer that's negative, a negative number. And when we're learning the 4 operations on fractions, we usually haven't explored that part of math yet where we have negative numbers. But the good news is that when you find yourself exploring that, and you find yourself in a position of having to do a subtraction of fractions, this technique that we're learning right now will still work. So it's nothing to be afraid of. Again, looking at the time, seeing how much time I have left, I want to do another examination like this. I like this, where I compared them. So I'm going to do another problem where I do it twice, and I try the lowest common denominator and a common denominator, and I compare the answers to see, is this pattern that we're noticing, is it still going to happen? I'd like to do that before I get into my word problems. Now, one of the word problems has been sitting here all this time, but I have another one as well. I just wanted to write one of them on the chalkboard wall before the class started because it takes a while to write down a word problem on a chalkboard wall. So at least one of them's already written. Okay, it's time for me to do some erasing. It's time for the students to do a stretch if you need it, a sit up or a jumping jack if you need it, and get a sip of water if you need that. You knew that was coming. You knew the was coming. Even Mocha knew it was coming. Her tail started wagging before I even did it. Okay. You know what else is happening? This is kind of interesting. I'm feeling hot now. So I'm taking off this sweater, this cardigan. That's what it really is. Uh-oh. My microphone is attached to it. So before I damage any equipment, I'm going to reattach the microphone. I hope you can still hear me while I was doing that. And this is happening why? Why am I no longer cold? It's because I'm thinking. It's because I've been doing a lot of thinking for the past 45-ish minutes. And thinking does burn energy. So it's kind of like exercising. You feel warmed up when you do a lot of thinking. That makes me feel good. It's nice to know that I'm actually burning energy while I learn. It makes sense. Okay, back on the armchair, please. Up. Okay, up. Lie down. Stay. If I have to, I'll bring her to the door and put her through the door so she can go upstairs. I was hoping to avoid that because of the fact that I have a microphone attached to me and I don't want to have to take it off. And also because I don't really like to leave students in a classroom waiting while the teacher disappears from his Zoom rectangle. And, you know, that might be boring for the students. I don't want it to be boring for the students. Okay. So what is the next one I want to do and compare? I'm going to do 1/6 plus 3/4. Okay, now, that shortcut, if you will, to find a common denominator without worrying about whether it's least, is to multiply the denominators we have. 6 times 4. 6 times 4 is equal to 24. We know our multiplication table, so we know that. So it's a very fast way, if you want, to get a common denominator. 6 times 4 is 24, so that means my common denominator will be 24. My CD, I'm not going to refer to it as an LCD because I know that's not necessarily the LCD. Sometimes it is, though. If you're adding 1/3 plus 1/5, 3 times 5 is 15. And we did a problem with 3 and 5 as the denominators before. 3 times 5 is 15, and that actually is the least common denominator. But it's not always going to happen. So when it doesn't happen, like here, we're still able to answer our question. How do I get 6 to turn into 24? I multiply it by 4. So I must multiply this 1 by 4, and I have 4/24, which is equivalent to 1/6. That makes sense. How do I get 4 to turn into 24? I multiply it by 6. So I'm multiplying the 3 by 6, and I have 18/24. My answer will, of course, have 24 as the denominator. And 4 plus 18 is equal to 22. And 22/24 is a perfectly good number. It is a correct answer. But if I am being asked to give my answer in lowest terms or fully simplified answer, that means I am not finished. 22/24 can be divided by a clever form of 1, and the lowest common factor of 22 and 24 is 2. So I'm going to use 2/2 as my clever form of 1. 22 divided by 2 is equal to 11. 24 divided by 2 is equal to, oops, messy, 12. 11/12 is my answer. It is equivalent to 22/24, so it cannot be simplified further. That worked, and it was fun. Let's do this one again. I'm trying to leave room. I think I'm going to have to go down to the next space on my page, if you will. But I'm able to still build my skeleton this way. Okay, 6 and 4. What is the least common denominator? What is the lowest common multiple of 6 and 4? I'm going to start with 6, and I'm going to list the multiples of 6, and I'm going to think about whether any of them are also multiples of 4. 6, 12, I did it already. 12 is a multiple of 4. I didn't have to list very many multiples of 6. 6, 12, 18, 24, 30, 36. I am actually seeing that there's going to be quite a few multiples of 4 involved. But 12 is a multiple of 6, and it is also a multiple of 4. So 12, can that be my least common multiple? Have to be careful. 6 doesn't work. 12 is the next one. It's going to have to be the least common multiple, the least common denominator, because when I list all of the multiples of 6, the only one before 12 is 6, and I know that 6 is not a multiple of 4. It makes you think. It makes you think about multiples and what they mean. Okay, to get 6 to turn into 12, I multiply it by 2. So 1 times 2 must also be done, and I have 2/12. To get 4 to turn into 12, I multiply it by 3. So 3 times 3 must also happen up here. I'm multiplying by 3 over 3. 3 times 3 is 9. I now have a common denominator. I have an addition over common denominator. I can add. My answer has 12 as the denominator. 2 plus 9 is equal to 11. Can 11/12 be reduced? No. So by finding the least common denominator, I had to slow down at the beginning to make sure I got the least. But then I got an answer that was already simplified. To use any common denominator without worrying about whether it's least, I managed to get the answer, and I got the correct answer at the end, but I had an extra step to do at the end. Which is better? Neither is better. They're both good. They're both techniques that work. So we should not be, we should not have to choose which one's better, which one's more efficient. I'm not sure if I can even answer that question. I think they're both efficient. So doing the problem twice, 2 different ways is a good way to learn something about what you're doing, because it makes you slow down and stop and think about what you're doing. Looking at the time. Okay, I have looked at all of the questions that I see up there. Now I am going into the word problems. I only have 2 word problems prepared, but I have a feeling the time that's left is going to be required for me to do both of them. Fortunately, the Vanessa one is already written on the chalkboard wall. And of course, I did promise at the beginning that when I got to that word problem, I would show you the other autumn wreath that Vanessa made for another grandchild. She only has 2 of them made so far, but there are more. Oh, watch out, the microphone cord. Okay, but there are more than 2 grandchildren. So there are more autumn wreaths in our future. So this is the one I showed you before. It's orange, and it has all these embellishments on the top. But that's not the only way to do it. As brilliant artists like my bunny rabbit Vanessa know. Here's another one. And this one has the embellishments at the bottom. So very cute, very pretty. She makes lovely things. And what better thing to do on a cold October day than like it was on Monday, which was the day that she made these, than to make something beautiful. That's why we like crafts. Okay, so Vanessa makes 20 autumn wreaths. Okay, she hasn't made 20 yet. So we're saying, okay, maybe this is the plan, maybe this is last year, I don't know. Vanessa makes 20 autumn wreaths. 10 are for the craft fair. 1/5 are for the grandkids. And the rest are for friends. How many are for friends? So that's the question. I realize it's been sitting there all through the class, so the students may have answered the question long ago, but that's okay. I'm still going to go through and do it. The problem with this, watch out for that microphone cord, is I want to do a fractions problem. That's what I was making up. And I see 1/5, so that's a fraction. Fractions are involved in here. And I can see the situation. It looks like I'm going to be adding or subtracting. Are we surprised? No. But 10 isn't a fraction. So if I want to do a fraction problem with this, if I want to solve it with the fraction, Well, I'm using this fraction here. I want to make the other number a fraction. How will I do that? So 10 are for the craft fair out of 20. So the fraction 10 out of 20, 10/20ths, works. I convert this 10 and that 20 into a fraction that quickly. 10/20ths are for the craft fair, and 1/5 are for the grandkids. Now, should I use 10/20ths or should I simplify it? Well, I guess we could do this problem both ways. So, I'm going to add together the ones that are for the craft fair and the ones that are for the grandkids, because it's going to allow me to figure out the answer to this question. 10/20ths plus 1/5. Here I am adding fractions. I need a common denominator. What is the lowest common denominator of 20 and 5? I know the students already know the answer, but I'm still going to start listing multiples. Not for very long with the 20, 5, 5, 10, 15. We're not surprised to see 20 happening on that list. I have enough. My common denominator can be 20, and in fact, that will be my least common denominator because it is the smallest number that's on both lists. So I'm going to convert this into two fractions that have 20 as the denominator. And we got lucky. One of them already has 20 as a denominator, so 10/20ths doesn't have to be expanded, but 1/5 does. 5, I get 5 to turn into 20 by multiplying it by 4. So I will multiply 1 by 4. 1 times 4 is equal to 4. I'm nearly there. My answer will have 20 as the denominator, and 10 plus 4 is equal to 14. So 14/20ths of the wreaths are for either the craft fair or the grandkids. The rest must be for friends, which is what we're looking for. 14. Now, the fact that this fraction is already over 20 makes it kind of easy to figure out the final step. If there are 20 in total, and the amount I have is 14, I can subtract. And 20 minus 14 means 6 wreaths. Do I have room for this to show? 6 wreaths, writing it really small so that it'll fit. Yeah, kind of fit. 4 friends. Remember, give a complete answer. The unit of measure is wreaths this time. That's what we do with word problems. It worked. Now, that was one way of doing it. What am I doing for time? I think if I had decided to reduce 10/20ths, that would have given me another approach to the problem, which will look a little different, but I'm not going to do it over again because I won't have time to do my second problem. And the problem with the second problem is that I haven't written it on the chalkboard wall. So maybe I'll do it without writing it, because I think I'll use all of the remaining minutes of the time if I try to write this out. So what I'm going to do is write the keywords and I'll just say it out loud. Okay, a project. Now we had a problem that was about Vanessa with her craft. And so we need a problem that's about Doug with his craft. A project requires me to glue together 3 pieces of wood that are 1/2 inch and 1/4 inch and 3/16 inches in thickness. And these are common thicknesses for wood of the type that I like to buy, exotic hardwoods that are nice looking when I do my projects, my crafts. Now, if I need my final piece to be 1 inch thick, how much am I missing? So that's kind of like a big subtraction. The interesting thing about these problems is you could form them into a subtraction problem, or you could form it into an addition problem, depending on how you want to build your steps. But what I'm going to do is I'm going to add these 3 together and see if they equal 1, or if they are smaller than 1, or even possibly if they're bigger than 1. So if I add 1/2 plus 1/4 plus 3/16, hey, you might be saying, there's 3 of them. Can we do that? And the answer is yes. Yes, we can do that. We can add 3 fractions together at once if we wish. We can do it 2 different ways. We could add the first 2, get an answer, and then add the answer to 3/16, or we can do it all at once. If we're doing it all at once, we need a common denominator that's common for all three of these. So listing all the multiples would take a while for 2, 4, and 16. So I'm going to try to do it the shortcutty way. I'm going to start with 16, and I'm going to ask myself, is 16, which is the smallest possible multiple of 16, is it also a multiple of 4? Yes. And is it also a multiple of 2? Yes. And that is kind of convenient, but one of the reasons I like woodworking, because the fractions that you deal with in this hobby can often work together really well. So if I'm going to use 16 as my common denominator, then 3/16 is already over the common. To get 4 to turn into 16, I multiply it by 4. So the 1 has to be multiplied by 4, and I have 4/16. I may be going a little too fast, but I kind of have to because I'm nearly out of time. To get 2 to turn into 16, I'll multiply it by 8. So I multiply this 1 by 8, and I get 8/16. At this point, I'm able to add these three fractions together. The answer will have 16 as the denominator. 8 plus 4 is equal to 12, plus 3 is equal to 15. No, I have not reached my final thickness of 1 inch. This is a little bit smaller than 1 inch. And I can even solve the final little problem, how much I'm missing, by saying 1 inch minus 15/16. So now in the same word problem, I've done an addition with 3 fractions. It's crazy, but I'm also doing a subtraction. And I fit this equals, I need a common denominator. What do? We've seen this with multiplication and division. This is really having trouble fitting. What do we do when we have a whole number and we need it to be a fraction? We put it over 1. So 1 over 1 is equal to 1. And now I have a fraction. How do I get 1 to turn into 16? I multiply it by 16. So the 1 on the top must also have to be multiplied by 16. I get 16/16 minus 15/16. Remember, this one didn't have to be expanded. 16 minus 15 is equal to 1. The denominator is the same. I am 1/16 inch. I guess I have to write my answer of wood missing. That was kind of a complicated word problem. I didn't even write it down, but we were still able to do it using the skills that we've been discussing today. And that is how powerful these skills are. So I have gotten to the end of my time. I have to say goodbye. I am going to let Mocha say goodbye. She has been a very good girl, very patiently waiting while I went through all those fractions, and it's her supper time, and that's what she is thinking about. So thank you very much for joining me at Fractions with Doug. You are supercharged. It is always a blast to teach you, and I look forward to seeing you next time. At this point, I'm just going to wave goodbye and look at the chat.